we're going to create a system that has a dedicated front-end application and a dedicated back-end application. In this particular video, we'll take a look at the back-end portion of one particular feature. And the particular feature that we'll be creating is this scrollable feed here. So there is some data here, and this is running inside of a browser, and this browser is sending some requests to a backend application. So there is a server, and that server is responsible for sending some data that we can see here inside of the browser. So we're going to take a look at how the server actually sends this data and how we can store it and how we can retrieve it. So this is just one particular look at how we can create one particular feature. And for creating the backend portion, we're going to be using .NET. In particular, we're going to be using .NET version 8. The language that we'll be writing the code in is called C#, but when you install .NET version 8, you will also get C# with it. If you do not have .NET installed on your system, you can go to this site here. I'll leave the address in the description of the video, so you can just click that link. And in here, you can download .NET version 8. So this is the newest of the newest. You'll see that it says preview right here. So the stable release is right around the corner. And since this is an even number, it means it's a long-term supported version. So you can use .NET 8 for years to come. So just scroll down and then you just pick whatever system you have, and then you just follow the installation instructions. Once you're done with the installation, you pull up some kind of a terminal. I recommend you using Git Bash. If you are on a Mac system, you can just use the default terminal. And if you're on Linux, you can also use the default terminal. And what you're going to do to figure out if you have successfully installed .NET is write .NET list SDKs. So I have version 8 installed and version 7 and version 6. So I'll get a couple different here. And you can also write .NET list runtimes. And I also have a couple different runtimes installed. But if you want to be able to write the same code as me, just have .NET version 8 installed on your system. So now we're going to get started making an application here. So the first thing we're going to do is we're going to create a C# project. So the command for writing a new C# project with the .NET CLI is .NET new. And if you just write it like this, it's going to tell you that this creates a new .NET project based on a template, yada, yada, yada. And then they have different languages, of course, because inside of the .NET ecosystem, there are several languages. Very interesting. And we're only going to look at C#. And the reason why they put it inside of brackets is because this is the default one you'll get if you don't specify another language. We're going to be creating a web API. So I'm going to write .NET new web API. Okay, so I just opened up the project we just created with the CLI using Rider. I suppose most people will either use Rider as an IDE or Visual Studio or VS Code. I will be doing all of the demonstration with Rider. So if you want to have the same UI as me, just use Rider. So I'll just show you real quick here. This is the file system overview here. If you just open this one, this is the directory. And if you open this one, you will get the project. So when you first open up the project, you will either get the file system overview, it looks like this, or you will get the solution overview. The file system overview shows absolutely everything that you have, but the solution overview does not. So things like your bin folder or your object folder or things that are outside of C# projects are not shown in the solution overview. Some people like this one because they think it's more clean. I, by default, always use the file system overview so I can see absolutely everything that I have. But that's, of course, just a development preference. And the default application that you'll get when you just use the CLI to create a new project is this one. It's called Weather Forecast. So the idea of the default application is that you run the application and then you can send a request to the server, and then the server responds with a weather forecast. And before we'll take a look at all of the files, I'll just show you what the program does. So if you open up the terminal here, and if you're inside of the, as long as you're inside of the directory that has the .csproj file, you can run this one. So if you write .net run, that is the command for executing. So first it will go through a building phase. It'll build the source code that you have into what we call a .dll file, and then it will execute that .dll file behind the scenes. And once it's successfully running, you will get this message here that it's running on localhost port 5058, I think it says right here. Which means that if you open up a browser, so let's get our browser over here. If we enter the address that the program gives us inside of our address bar inside of our browser, and just write the name of the protocol that we're using first, then we can get this weather forecast here. So what we're being presented with here is the data in a format called JSON. So essentially, the program says, hey, there is someone who's requesting some resource, and then it's responding with some data. So this is what we're going to be building. We're just going to be doing it with the book feed. So we're going to be changing everything, but it's the same concept. You send a request, and then you get a response. Let's take a look at all these files. So I mentioned just previously that there's something called the CSPROJ file, stands for C# project. So this file describes the project, like what are your dependencies. We can see that there are some packages that we're relying on here. We'll get back to what these are, and then it tells us what the version is. So I have several versions installed, like I showed you previously. So that's why it defaulted to version 7, because 7 is the newest stable release, and 8 is right around the corner. If we change it to 8, you can always just change it manually by just changing the number here and writing .net build. Now it's building again, but now it's building it as a version 8 application. You're not really going to be changing this file manually, but it's absolutely vital that it exists because you cannot go without it. And you have this file called program.cs. The program.cs is a startup file. This is where your program starts. And notice that there is no starting method. This is a pretty new thing in .NET. It's called a top-level statement, and it means that we'll just start executing from the first line. So we're creating something called the builder. We can see here in the inlay hint that the builder is a type of web application builder. So all you need to know here is that this is just some configuration, and some of this stuff that we're not really going to be using right now, we can just delete it. And then there are some comments in here. It's not super interesting for now. And then we have a class here called weather forecast. So this is just a business entity for the weather forecast. We can just delete it right away because we're not going to be making weather forecasting. We have something called app settings.json that we're not going to modify right now. We have something called properties.json that I am going to modify because right now it defaults to run on localhost port 5058, and I think that's a very random number. So I'm going to change it to 5000 so I always can remember what port it's running on. Then you also have the OBJ folder. It contains temporaries. You should not change this folder. And you also have another folder here that you should not be changing. It's called the bin. So this is where you're building the application to. So we can see that there's something called .NET 8.0. We just changed the version real quick previously. And I mentioned that we are compiling to something called DLL. This is a DLL file right here. If we go into the bin folder here and we go into the debug folder and we go into the .NET 8.0 folder and we write .NET and then just write the name of the application library.dll here, we will also be executing the program. So right now the program is running once again. And we didn't compile it again. I think if we compile right now, we'll get a compile error because we just deleted the business entity. Anyways, you're not going to be modifying the bin folder and you should not be modifying the object folder. What you should be doing is you should be git ignoring both of these. So make a file called git ignore and just write bin and obj here. So you're not going to be committing those folders to your version control. So this is where all of the magic happens, or whatever you want to say. This is the controller that is responsible for sending the data to the requester. So we have a public class called weather forecast controller that extends the controller base. This is the C# version of writing extends. So this is subclassing a superclass here. Is you just write semicolon. It's the same way you implement an interface in C#. And then there is a route here. We don't really need that. And then they have just an array of some stuff here. And they also use a logger. We can let that one stay. And then they have this thing here. So this is what we would reference as being an endpoint. So we have some HTTP method here. Notice that inside of the browser, it said HTTP and then some address. So HTTP is a protocol, stands for Hypertext Transfer Protocol. So we're writing send an HTTP request and reach this point here. So we're just going to change the behavior of this one. I'm going to say public object, and it doesn't matter what the method is called here. And then I'm going to write an attribute here. This is what we call attributes in C#. And now we'll just write a string, and this string references the route that the requester must be requesting in order to reach this method here. So let's just write blah here, and then we will return some object, return hey. And then let's rerun this program now. I'll just go back into the folder that has the CSPROJ here, and then I'm going to write .NET run. And now it's going to recompile, and then it's going to execute all over again. And then we're going to pull up the browser here. And instead of writing localhost port 5058, which I changed, we're just going to go 5000 / blah. And now we're going to get this hey. So we're sending a request to this route here. And we're going to get some response back. So of course, object, that can be anything. It doesn't really say anything about anything, because in C#, even primitives inherit from object. So unlike a language like Java, where primitives are not objects, in C#, this is also an object. That's why you can say int k equals 2, and then you can reference k, and then you have methods on top of k, like equals and compared to, and yada, yada, yada. So you can say primitives, or what we also reference as built-in types in C#. They are actually very powerful. Anyways, we're going to return something here. And this is, of course, a book feed that we're making. So we're interested in making a class called books. And then we can respond with some book that has some data. So let's write return new, and then we make some kind of object here. So inside of this object, we'll create some kind of key value system. So it's just like a regular class. Gonna write title, Harry Potter 1, the Sorcerer's Stone. I think that's what it's called. So right now we just have an anonymous object. This is what's called an anonymous object. We don't really need to specify the class, but we can do that. If you open up the context menu and you write to name type, it'll ask you, hey, do you want to create a class here? And we can just call it book. So now we have a book type. And if you go into this book class, you can see that we have it right up here. This is a very weird place for a class. Let's move it somewhere else. Move it outside of this class. And now we create a new book. So beautiful. Let's run this application once again. And if we refresh, we can see that we now have title, Harry Potter 1, the Sorcerer's Stone. So when we look at this data, our browser does not know that this is a book object. The framework for creating this That means when you get data like this, your browser does only understand very basic formats. It doesn't know what programming language the backend is made in. This could be a Java-based HTTP server like a Java Spring, or it could be a Ruby, or it could be any sort of language. It just understands this is JSON right here. And actually, I'm gonna open up the networks tab here. So if you open up the browser developer tools, the easiest way is just to go down into inspect. Most browsers, they have something called inspect. And then you can open up this section here where you have console and sources and yada, yada, yada. Then if you go to the networks tab and you refresh right here, then we can see that we're sending a request here. It's just listing all of the requests that's coming out of our browser. So the browser has an HTTP client responsible for requesting HTTP servers. And then the server serves some data back to the client. It's a brilliant system. And we can see that this is the response. We can also go look at the request here. So the request is a bunch of data that we're sending. So all of this data is just something that the browser is building into the request. So we don't need to specify any of this manually. And the HTTP server takes a look at this request here, and then it's making a response. So we have some response headers. You can see here it says server Kestrel. So Kestrel is the name of the web server that .NET uses. And we can also see that there is a particular format here. So of course, you might have heard about formats like ASCII and Unicode. This is the format UTF-8 for the data that we're sending. And I mentioned that we're using something called JSON. Absolutely, this is a JSON formatted response. So you can always go in here and see what your browser is actually receiving of data, but also what kind of requests that your browser is sending. It doesn't matter if it's this application that we're building ourselves, or you go to or if you go to an address google.dk, then you can also see everything that's going on here and all of these requests that apparently your browser is sending and some responses that you're getting back. And of course, we're going to talk tons about the developer tools. Anyways, we're going to get back to this application now, because right now we're just sending some hard-coded data. But we're of course interested in sending some data that comes from a database somewhere, so we can safely store and persist some data on the server side, and then the server is responsible for sending some data to the client application once the client needs some data. The database that I'm going to be using for this demonstration is called Postgres. And particularly, I'm going to use the hosting service called ElephantSQL. ElephantSQL has a very generous free tier where you don't need to sign up with a credit card or anything. You can just go to ElephantSQL.com. So what you do is you go in here and you sign up for a free plan. And the most important factor in picking any software for a course like this is that I want to provide you with some software that's open source. So you can download and run Postgres locally on your own system. So if you ever want to insert a billion rows or anything like that without having to worry about data cap or anything like that, you can just run it on your own machine. So if you want to do something completely offline, you can do that. You can do whatever you want with it. It's open source. And this managed plan right here is very generous. It has 20 megabytes. So 20 megabytes, that's a lot of data if you're just storing things like text. And they give you a connection string right here. So of course, if you click the I here, you get the full connection string with passwords. I'm not gonna click it right now, but what you do is you go in here, you sign up for a free plan at ElephantSQL, or you just download Postgres locally. And then you can use this from your application. And I'm gonna show you how to connect to this database from your .NET application. But first off, if you just want to write some basic queries, you can use their browser here, and then you can just select everything from yada, yada, yada. This SQL browser is not the most feature-rich. Personally, I like to use the application called DataGrip for just database management. if you open up your JetBrains toolbox, which you supposedly have if you have any JetBrains-based IDE, you can just download DataGrip from there. DataGrip looks like this, and you can see I have a connection to the ElephantSQL database. And you can also see that I also have Postgres running locally on my own machine. And you can just click this plus icon here and click data source, and you can see that they have almost any major DBMS in the world in here. So if you want to use something completely different, you can also use DataGrip for it. Anyways, you just go in here and then you pick PostgreSQL. Then you'll get this little connection UI, and you can just enter your credentials, and then you can create your book table or whatever tables you want to have. All right, so we're back into our application now, and I'm just gonna quickly rename the weather controller here. So I'm gonna call this one book controller, and it's also gonna rename the file. Anyways, we're gonna create several C# projects. So C# projects, they can use each other as references. So it's a very general thing when you program, you want to divide things into separate concerns. And the concern for this application that we have right here is just to respond to HTTP requests. So it's also what we would call an API. There are many types of API. Some would call it a REST API. Some would just call it a JSON-based HTTP server. Anyways, it's not so important what we call it. The concept is more important. We're responding to some requests. So when we need to manage something like databases, we would of course make a separate C# project. And then this C# project can call things inside of another C# project. So we're going to go for a layered architecture. So we're going to create something called a service, and then this service can call something called infrastructure, and then this infrastructure project can call the database. So because I just have this library as a C# project lying somewhere inside of my home folder, I'm going to create a directory called library system, like this. And then I'm going to move the library into this folder called library system. So sudo mv library system. And now if you go into library system, so now we just know that the library is just the API portion. So of course, if I was a little more foreseeing, I would have created the subfolder previously. It doesn't really matter. So now we're actually going to structure things a little bit. So this library here, I'm just going to call this one API. And I'm going to rename this one API.csproj. And now I'm going to make two separate directories here, one called service, and I'm going to make one called infrastructure. Now I'm going to go into service, and I'm going to write .NET new classlet. So class libraries are not executable programs like APIs or like console applications. But an API or a console application can call methods inside class libraries. So it's just a CS project responsible for being a service for another CS project. And I'm also going to go into infrastructure and do the same thing. So go to infrastructure, cd, I just misspelled infrastructure. And I'm going to write .NET new class library. And the way that we organize things in C# is that we create solution files, and then we add the projects to the solution. So I know right now we have a lot of concepts, but just stick with me for a moment. I'm going to go into the library system, and I'm going to write .NET new SLN. SLN is shorthand for solution. So the solution file needs to know about the CS projects we have. So we have one CS project here, we have one CS project here, and we have one CS project in the API that we created in the beginning. So you can use the command .NET sln add, and then you just point to the CS project, API/API.csproj. And now it's going to say project, add to the solution, and we do the same for service.csproj, and we do the same for infrastructure. Infrastructure.csproj. All right, so right now we don't have any solution overview, but we do have the file system overview. If you also want the solution overview, just right-click the solution and press Open Solution. And now this is the final structure that we're gonna go with. We have one solution containing 3 separate projects. Each project has its own responsibility. And the way that we're gonna make the API know about the service and the service know about the infrastructure is we'll just add a reference. So you can go in here and then you can click on Add Reference. And then you can just check mark it like this. There is also a CLI command for this. We can use it for adding the reference from service to infrastructure. If we go into service here and write .NET add reference, and then write dot for going back one step in the file system, and then writing infrastructure, infrastructure.csproj. We now also have a reference from the service to the infrastructure. So now it's a 3-layered architecture, as you might be able to figure out by now. And of course, all of this, if you start out a completely new project, the most sensible thing is to just create the empty solution file and then just go into the empty solution file and then just add a new project. And then you get a graphical user interface of different types of projects. So the last couple of projects we were adding were class projects. So you can just go in here, pick a version or whatever. But of course, I'm always going to demonstrate the CLI version, because if some of you don't use Writer, if you like something else, then of course it doesn't make sense that I just only rely on the graphical user interface to do it. So I demonstrated both styles here. Anyways, we're going to start connecting to the database. And what we need to get is we need to get this connection string here. So just copy your connect string. There is also a copy button here. And we're going to add this as an environment variable. So environment variables, of course, depend on your operating system. If you use Git Bash or the terminal that's built into Mac OS or Linux, you can just write export and then the name of an environment variable. So I'm going to use pgconn, and then you add this little equal sign here, and then you paste your connection string with the secret. And of course, I'm not going to show this in the video. If you use Git Bash on a Windows machine, it'll be there for the remaining of the terminal session, but it won't be there forever, which means that if you want it to stay here forever, of course, it should be your own machine that you're working on right now. Then you should go into your system environment variables and add it manually. Of course, if you're a reckless person and you don't care about any of that, you could hard code it and put it into your code. I would never recommend anyone doing that. You should always add it as an environment variable for security reasons, but you could technically do that. So I've already added my environment variable and call it pgconn. So now we're gonna create something that references this environment variable. And you can just take mine and just paste it in, because it's gonna be the same for all of us. I'm just gonna rename this one and call it utilities. So there's gonna be a utility class inside of our infrastructure that is just responsible for all this connection stuff. I'll briefly explain what I'm inserting here, but you're gonna use the exact same thing here. So we're referencing the environment variable we just created by writing pgconn as a string here. So anywhere inside of C# programs, you can reference the environment. And because the library that we're going to use to connect to the database wants the string to look like this, but ElephantSQL makes the string look like this, I just made a method that rewrites the string. So you can just paste this one into your program and it'll work the first time. So I mentioned that we're going to use a library for connecting to the database because .NET doesn't know what the database system is. So there is a very clever system for installing packages into .NET applications called Nuget. And Nuget has a package called npgsql. And this npgsql, we need to install into the project that we call infrastructure. So we use this just like you would use JDBC in a Java application for connecting to a database. Almost any language that you're going to be connecting to any kind of database in, you either need a driver or some kind of connection library. So this is completely normal procedure. And we're also going to install a package called Dapper. So Dapper is classified as being a micro-ORM. ORM stands for Object Relational Mapper. So tables inside of databases are formally called relations. And we can map these relations to objects inside of our C# program. So if you just install Dapper into your infrastructure project as well, we now have these two packages. If you open up the file system and you go to infrastructure and you go to the CSPROJ, you can now see that you have these two packages installed. If you ever delete your bin or your object folder or anything like that, you can always get your packages back by going into the directory with the CSPROJ file and write .NET restore. It will rebuild the packages that you need. So in this instance, we'll get these packages back here. So when we want to use these packages in order to send some queries to our database, what I'll do is I'll make a directory called repositories. And inside of this repositories directory, I'll make a class called book repository.cs. This book repository requires what we call a data source. So right here, I'm just making a constructor real quick, and I'm going to use what I call data source. So inside of the library that we just installed, there is something called npgsql data source. And I'm going to create an instance variable here, private npgsql data source. And the instance variables are always referenced using underscore first. And this data source here, I'm going to say data source equals data source. So what we're going to do now is we're going to create a method here that is an IEnumerable of some type. So IEnumerable is just a linear data structure. If you hover over this and open up the quick docs, you can see that it exposes the enumerator, which supports a simple iteration over a collection of a specified type. So if you remember all your design patterns, you know that iteration is just, you're running over some linear data structure of items. So let's create a type for this IEnumerable. I'm going to call this book query. I'm going to call this book feed query. And I'm going to call this get books for feed. And then I'm going to make scope here. And here I'm just going to create a type here. And inside of the class, I'm going to create some properties. So properties in C#, they are kind of a funny thing because they're not fields. I'm going to make a property called public string. And then it's going to be book title. And this is when it's going to start to get crazy. This is called the accessors here. So we don't create fields and then make getters and setters for them. We make accessors for properties. So this property here is not a field. This here, private string book title, is a field. And then you could, of course, make a method that gets this. But this is different from this. And this is the convention in C# to make a property and then make this. Like you could still have a field. Like this is a field right here. We don't have any accessors on here. If we start writing get set here, it's going to say now you have the wrong conventions. You should rename this to data source because properties should be uppercase And then this is an instance variable. It also says this right here. And if we remove the accessors here, it's going to say that this is find convention. This is a field. So let's add some more properties to this class called book feed query. I'm going to make something called public int book ID and also make a getter setter. And I'm going to make something public string cover image URL get set. And let's make a public string author. Okay, so we have some data about this particular book right here. And now inside of this, we're gonna make a SQL query. So I'm gonna make a string called SQL. And what I'm gonna do is right before the string, I'm gonna add this @ and I'm also gonna add the $. So the $sign makes interpolation inside of the string possible. So we can put in variables. So let's say that you have a variable, you can put it in here. If you don't have the $sign, it's not gonna know what the curly brackets do. So without the $sign, the curly brackets are just curly brackets. And the query that we're gonna use is select, and now we're gonna specify the columns. So I'm gonna make a table called books, and this books is gonna have all of these different columns. And we're gonna follow Postgres conventions for naming. You can use uppercase for the keywords here, but the columns should be lowercase because Postgres is case insensitive. So I'm gonna write book title. So I'm gonna say S, and then name of, and then I'm gonna write book feed query. And then I'm gonna reference the property that I wanna use here. So this way, if I rename this, let's say that I rename this to something else, I get the type safety. So I can rename things without breaking the queries. That's very clever, right? I'm just gonna name this back book title, select book title as, I'm just gonna write the rest of this query so you don't have to look at me writing boring queries. All right, we're back, and I'll just explain real quick what I have right here. So this is the query that selects all of these different columns from the table called books. One thing about Postgres that is different from some other SQL databases is that they use this thing called schema. Schemas, they are containers for tables. They also have other things than tables, but primarily speaking, you have tables that relate to a schema. So you can create another schema that relates to another project, and that project has some tables. That's kind of how you can think about it. And if you're using the extension for databases inside of Writer, you can introspect the database. So you might be able to see here that this is highlighted. This is of course different from if you just have a string that does not have any syntax highlighting. So if you don't get this, you should press Alt and Enter here, and then you probably get some context menu action that is called introspect database. So if you can see your database out here, you should be able to introspect it. If you do not see it out here, you add it as a data source. So you go in here and you press PostgreSQL, and then you enter your credentials to the database that you have on ElephantSQL. And then when you're writing your queries, sorry about that, when you're writing your queries, you also get IntelliSense. So let's say that you want to reference your tables here. You can see, okay, you have a table here called books. You also have something called a sequence and yada, yada, yada. So it's easier to write queries this way. Anyways, now we have a query and we want to execute this query and get the results out. So the way that we're doing this is that we're taking this data source that we have as an instance variable or as a field up here, and then we're writing using. So inside of these parentheses, we're gonna write var con for connection, and then we can reference the data source and write open connection. So this is not too different from what other frameworks and languages use. And then here on the connection here, you can write query. And then this query here comes from the Dapper library. So Dapper is capable of taking the outcome of the query and then mapping it to some object. And then inside of this query here, you can put in diamond brackets and then you can give it a type. So I'm just going to give the type that we have right here, book feed query, and just put in book feed query. And then you take the string here that we call SQL. And you can also put parameters in here. So let's say that you have an insert statement. You pass the parameters in here. You can use an object from a class, or you can use an anonymous object, just like we were looking at previously. So let's say that you have something called title, and you want to insert a title. You could just do it like this. Anyways, we don't need to pass any data in here. This is perfectly fine just with the string. And now we need to call this method here from the service. So now we don't need to go into the service. We don't have any classes inside the service. I think there's one called class 1. We can just use that. And we can just rename the class here to something like books service. We're not going to have a ton of stuff in here. It's going to be almost empty. We're going to make a constructor, public book service. And then this book service is going to require the book repository. And we're going to make a field here private. And often we make fields read only if possible. And then we're going to make the type here, book repository, and give it a name. Should be undercase first or underscore first, and then the name camel case. And now we say that the book repository field is equals to the injected book repository here. And we can create a method that calls the book repository method we just created previously. And we're going to say return an IEnumerable of book feed query, and just call this get books for feed. And return book repository get, and then the API layer. Let's go into the controller class that we were using to send data to the client first. Book controller here. Instead of just returning some hard-coded object, we're going to inject the book service into here. Book service, and up here, private read-only book service. Book service. Yeah, there's a lot of boilerplate in object-oriented programming. Book service. All right. And now we reference this. Return book service. Get books for feed. We don't have to change the return type here, but of course we can say that this is an IEnumerable of book feed query. And now this is where it starts to get really clever, because .NET has a very, very fancy way of dependency injecting. So you might have noticed that at no point in time are we manually instantiating the book service. We're only requiring it inside of some constructor, just like the book service is requiring the book repository, and the book repository is requiring this data source. You see, where do all of these things come from? Let's go into the program.cs, and I'll show you here. So when we need to use the repository somewhere, you see the repository is used by the service. We go in here and then we say builder, services, and then we add a service as some form, like we can use a singleton pattern here. If you remember your design patterns, you know what a singleton is. We can say that we have a singleton of the book repository. So now when the service, let's go into the book service. Now when the book service says, I want a book repository, it can automatically get a singleton of the book repository, because inside of this program CS file, we specify that there exists a global accessible instance of the book repository. We don't manually write new book repository. This happens under the hood. So it's really, really clever. And we also need to do that with the book service. So we can say, so let's just say book services add singleton book service like this. And you might also notice that at no point in time are we actually injecting the data source. We have the connection string, and we need to use that connection string right now. Let's open up the Nuget package manager here, and then we'll write npg SQL. And then there is something called dependency injection. So this dependency injection package we need to put into API, because API is where we have this file right here. And just like with when I was writing the database query, I'm just gonna show you the boilerplate stuff here, and then I'll explain it to you. So using the same web application builder as before, this builder instance here, we add the data source for Postgres. And remember when we were using the connection string to format into this right here, we're now using it. So we're taking the connection string and we're adding into the web application builder services. So now that the repository requires some kind of data source, it already has a data source because of this dependency injection framework. And also, you might notice that there are two scopes here. One is if the environment of the application is a development environment. At some point, your customer or your boss or whatever, they want this code to run in some kind of production environment. So when it is delivered, it is in production environment. You won't be using the parameter logging. So parameter logging is just something we use for debugging purposes. It also says here that you should only use this in development mode. So just so you know, this is something that you should be cautious with, but when you just run this locally on your own machine, it's very helpful for debugging purposes. And of course, there's just one little detail we need here is to return this. And of course, if you want to be sure that you have the exact same database setup as I have, I'll publish this code on GitHub. And what I'll do is I'll go into the database tool here, and then I'll write this generate command here. So there is this SQL generator that can just output this exact table here. So the only thing you have to change if you want to use the exact same database setup is the name to whatever database name you get on ElephantSQL. And one thing I always do is I always qualify objects with schema names. So right now, the schema is called library app and the table is called books. So I'll just take this one here. I'll copy this, minimize this, and then I'll just inside of a file in the root folder here, I'll just make a new file called generate table.sql. Now, if you open up the Explorer here, we'll have this file here. I'll just paste this in here. And if you recall from previously, we were making a git ignore inside of here. It's actually a little counterintuitive to just have it inside of one particular project because every project is a C# project. So we should make a git ignore file in the root folder and just put bin and obj inside of this one. So now we can commit this to GitHub and you can see the exact same code as I have. So now the program is ready to be executed. So what we're going to do now is we're going to go into our API because the API is what uses all of the other layers. We're going to write .NET run. So now the application is running once again, and hopefully with a little more content this time around. And now you pull up your web browser, and now you can go to localhost port 5000, and I think I was still calling the endpoint blah. So it's still on blah. You need to go. We can change that real quick. And now we have this data that comes from our database. So of course I was inserting a couple of rows into the database real quick with this random data. And this is the data that the front-end application needs to use. So if we change our endpoint here to something else, I think my front-end application wanted this content to be served on localhost port 5000/API/books. Let's go and change that real quick. Go into the route here, and this is just to follow conventions, API/books. So now we need to close down the program, run it once again. No, every time you change the behavior of the program, you should just run it once again, but it can respond to this request as many times as we want. And now that it's running, we can go to API/books, and we should see the exact same data, of course. So now before we can actually start using this from the other application that I created, we need to enable something called cross-origin resource sharing. Cross-origin resource sharing is just a setting that you change inside of program.cs. And it's gonna look almost identical for absolutely everyone. And this is primarily something we would enable if the client is a web browser. There are many types of HTTP clients that can bypass this setting. So it's not really a security setting, but you just need to have it there. This is totally just boilerplate code that you should just copy and put in. And there is one more thing that I want to show from inside of the program.cs file. And that is this thing here, add Swagger Gen. And then down here we have something called Swagger and Swagger UI that we are using. So if you open up your application, so go to localhost port 5000/Swagger, you get this page. So this is what we classify as living documentation. So we need to document our API. So right now we have one endpoint that is on this specific route, API/books, and we can send a request to it using this little graphical user interface that .NET just sets up for us. So this is very nifty, and it's good for just quickly testing some endpoints here. So right here, it gives you an example. So you're sending a specific request to this URL, and you're getting this response back. So this is just like if you took this address here, as long as it's a GET request, and you go into your address bar and you put it in here. So it's a very, very nifty thing for testing things. And if you wonder what this is, there is a command line interface tool called curl. If I just pull up a terminal here and I paste the command that they show us here, I can also get the data from here, which means that any HTTP client, it doesn't have to be a browser, it doesn't have to be any particular type of machine, anything that is capable of calling some HTTP server can now call our application that is running on this machine right now to get to our service, which gets to the repository, which gets to a Postgres database somewhere in Sweden on Amazon Web Services, where we have all of this data stored. And now that means our front-end application, let's just, I have the front-end application somewhere here on my machine. So right now I'm just starting the front-end application. We're not going to talk a whole lot about front-end right now. All you need to know is that the front-end application is running inside of the browser, and it is capable of sending the exact same request that we were using beforehand. So here we have the front-end application. Let's go into the Networks tab, and then we refresh this page here. And I'll just make it a little larger so you can actually see what's going on. And then we have some requests here to localhost port 5000/API/books, and it is a get type request. And we are getting this data, and then the UI just knows what to do with it. So it's a different program that is taking the data and presenting it in a particular way. So just to summarize, what we've made here is an HTTP server that responds to requests. The HTTP server is a particular type of C# project called a web API. This web API calls a class library in C#, which calls another class library in C#, which uses a database connection to go to a relational database, get some data, get it back into the application, tell the API, this is what you must respond with. Then the API responds to the HTTP client, and now we have some books. So this is still a super basic setup. There's a lot of layers here, and there are many new concepts, but this is still just scratching the surface of what we can do with an HTTP server in a distributed system. So right now, we're not getting any data in from the clients. We're not, creating a new book through the UI where, like, let's say some end user, they can input some new Harry Potter book, and then we can store it in the database. We're only actually getting data. So this is just the surface of what we can do with an API. Also, we're not doing any kind of exception handling. We're not doing any kind of data validation. We're not doing almost anything. So this is just, getting started. Most of this video is also just about setting up the project, setting up the correct structure that we want to use here on out, and just explaining all of these basic concepts. So in the next video, we'll start looking at other request types. So we're going to look at something like post requests, which is one that we use for creating new data. So the client can now send some data using JSON, and now the server should, of course, also be responsible for validating that data. So we're starting to get tons of new logic inside of our backend. And that also means we're going to have a service layer that isn't just, responding with calling a method inside of another layer. So the service right now is totally empty. But the main takeaway here is that web APIs are ways of creating backend systems for web clients to be using.